people aren't willing to trade utility and functionality for privacy. If we can first lower the barriers for developers so that they start building with privacy as a fundamental part of their apps, then consumers, when presented with a choice of, well, do I go with the private ChatGPT or the OpenAI one where I know they're keeping all of my data and I know they'll give it to the government, consumers will choose privacy.
So how do you see like the future as we enter this sort of age of AI? I mean, it's accelerating at such speed that you don't know what's next.
We're going to have a ton of these models that are going to be deeply integrated into our lives, that will need permission to use your credit card, that will need to access your email, that will need all this information about you. And so really the best way to impact the development of AI is going to be around building infrastructure that supports privacy now.
Hey, Sohejl here. Thanks for tuning in. Real quick before we begin, if you enjoyed this episode, if you learned something, please consider to follow or subscribe or share this episode. That helps us out a lot. It helps us to reach more people and to spread quality education across the space about crypto and Web3. Also, if you're part of a crypto project or represent one and you would like to come on the show or do sponsoring, please get in touch with us. And lastly, everything we talk about today is for educational purposes and no financial advice. Enjoy the show. All right, Alex, lovely to have you on the TEACHMEDEFI podcast.
Yeah, lovely to be here.
All right, let's get into it. We're going to talk about decentralized AI, obviously. I thought we started this off with Gavin Wood, obviously co-founder of Ethereum and Polkadot, and he coined the term less trust, more truth for blockchain and decentralized systems or decentralized networks overall, as in to have to less rely on blind trust towards humans and to be able to rely on transparent code or transparent rules on a global computer. And he also then wrote recently about AI, that AI sort of resembles more trust, less truth. So what is decentralized AI to you and why do we need it?
Yeah, so I would say that decentralized AI is really about how do we take a technology that has the potential to be integrated very deeply into our lives and use what we have learned from building consensus mechanisms in the layer ones that we have in the crypto space and build decentralized systems that focus just on the implementation of AI tools. And I think it's, to me, it's a very important topic. It's a very important part of the infrastructure of the new internet that we need to have in place. Because when I think about something like agentic AI, for example, right? If we want these agents that are going to come into our lives are going to be really deeply integrated into what we're doing and actually provide like an augmentation of our productivity, we're going to need to give them access to everything, right? All of this information about you, literally root access to your life. And if you're going to have a system that is, say, has that level of access and that level of intimate knowledge about you and knows that much information about you, we can't just put it in the hands of somebody like an OpenAI or a Google and expect them not to take advantage of that situation. And so if we're really going to have AI agents that are working for us and are not working for, big tech or big AI firms, then we need decentralized infrastructure that supports running AI in a way where you own the data, but you also have the ability to control the model that you're using, control the infrastructure that it's running on. And so decentralized AI is really about how do we create those rails and that infrastructure, utilizing what we've learned in Web3 and connecting it into blockchains to build a better version of AI that's really about the user and less about the big tech companies that are driving AI development right now.
Yeah, I obviously love that thesis. We were just chatting about that and that I work in AI myself for decentralized AI. So it's almost like the perfect marriage there in terms of bringing verifiability, cryptographic guarantees and confidentiality to that space, to AI. Maybe that's why there's so much happening, even though you always in crypto get like something is probably promising and then immediately you get a lot of hype and vaporware as well. How does that feel to you actually? What does that segment in crypto at the moment feel like to you?
I mean, I would say that the hype in AI is a net positive for the space because when I think about how crypto has evolved over time, like let's say cryptography, for example, prior to blockchain and prior to Ethereum and prior to these other layer ones that came in the 2017 wave, cryptography was basically, and blockchain especially, was a bunch of like super nerdy dudes in the back like room of the conference all standing in a circle talking about this like really cool theoretical concept. And what Bitcoin and Ethereum and all the L1s that came after that did was really put a lot of energy, a lot of mind share, a lot of brain power into thinking about cryptography and how we can build decentralized systems. So the breakthrough of proof of work was such a change to the landscape of how cryptography was done that it brought all these people in. It brought all these people in where they could work on this type of mathematics. They could work on improving consensus mechanisms. And so when we see the same kind of growth in DeFi or the same thing in like AI, we're shifting that mind share back in there again. We're getting people interested in how crypto systems can work with decentralized AI, how AI can live on crypto rails. And that is a net benefit to the amount of focus, energy, attention, and money that is flowing into something that I think needs to be fundamental technology. So basically, I believe decentralized AI needs to happen in the world. And so having more people pay attention to it, even if it's, hypey, great. Like more energy flowing towards it, the better.
Yeah, I hear you. How did you end up working on this?
On Nillion?
Yeah, on Nillion in this segment, yeah.
Yeah, so I would say my journey with privacy really started back when I was a kid. I was raised by two lawyers. And so in my household, I was very much taught, don't trust the government. Like that was a fundamental thesis. Like, the Constitution of the United States is there to protect you from the government because the government is going to try and get into all of your stuff. They would love to surveil everybody. They'd love to violate everybody's privacy, and there's only, say, these foundational principles of the United States that are protecting us from that happening, right? And as I grew up, things like Edward Snowden happened, things like Cambridge Analytica happened, and I'd always been a fanatical believer in the idea of privacy and how important privacy is to our ability to be able to think about the things we want to think about, to say the things we want to have a space where we're able to really own all of the things that are that make up who we are, right? Because as soon as you take something that is like incredibly private, like whatever things people have in their phones, and you start broadcasting that to everybody and that's accessible to everybody, you're going to start to self-censor the things that you're thinking about, the things that you do, the person that you are, the personality that you have. And so I always wanted to contribute to making the world safer in that way, right? Finding a place for there to be more privacy, finding a way for there to be, say, fewer people who are spying on your phone calls or, using your data to manipulate the way that you think. And in the rise of social media, like that became a bigger and bigger thing for me. The power that we gave to these tech giants in social media is huge. We don't really think about it that much because, you interact with Instagram or you interact with Facebook on your own accord. You open the app, you close the app, you post stuff on there, you comment on things. You're expecting this level of, say, you're putting information into the system. But that information that you were adding into a Facebook or into an Instagram, you can utilize that in a way where you can really start to slowly change people's perspectives on things like politics, for example. We've seen that in what happened with Cambridge Analytica. And so there's a lot of power in being able to, say, augment people's, or I guess adjust people's perception of things by understanding them very, very deeply. And so when I got the opportunity to get involved with Nillion, I met my co-founder Miguel and Andrew Masanto, who is a really good friend of mine, and they started iterating on this idea of how can we take privacy enhancing technologies, or what we call pets, and bring them into a place where they now have, we're reducing the barriers and the cost of using privacy tech to a low enough place to where developers can build with it, people can put it into applications. That was something that instantly spoke to me. And so, I had exited my last direct-to-consumer company. We were selling stuff on Amazon. It was cool. It was fun, but I didn't get a lot of meaning or purpose from it. I had exited that, and so I was ready to jump on board with Nillion and start bringing privacy back into the world.
Exciting. How do you think about actually the proliferation? Is that the proliferation? Yes, that's the word. How do you think about the proliferation of privacy primitives and adoption overall? Because, like you said, it's almost like people tend to be readily available to give their data away, right? Like, how does this change, or how do we move more towards these privacy primitives? For example, do we have to have like a component where there's even more utility there, or better UX, so that people change? Because it almost feels like as long as this app or whatever is useful and solving some problem for these people, they're quite inclined to not worry at all about the privacy part. It's just some disconnected thoughts that I have. Just what are your thoughts on this?
Yeah, I mean, this has been like the, say, fundamental problem that privacy has faced, right? It has been a world where, if you went and asked any individual, do you care about privacy? The answer to that question, they're going to answer yes, right? They're going to say that they do care. But when push comes to shove about like the things that they would do to maintain their privacy, you're exactly right. People aren't willing to trade utility and functionality for privacy. Nobody's going to go and delete, Instagram off their phone and Facebook off their phone, and even Telegram off of their phone, right? Because Telegram doesn't have the same privacy and encryption standards as Signal. They're not going to go and make those changes, even though they say that they care about privacy. I actually equate it a lot to health, because I think there's a lot of overlap there of like there are people out there who are, say, in the same vein of like privacy crazy people like me who, are going to bring all of their workout clothes with them when they go on holiday, and they're always going to find like the healthy meal in the sea of unhealthy things, and there's foods that they're going to avoid. But there are a vast majority of people who care about their health but also don't do the things to maintain it. And so privacy very much is in that same vein, right, where we care about it, we want it, but we're not willing to sacrifice utility and functionality in our lives to achieve it. And so I've always looked at it as, this is a reality of the space, but I fundamentally believe that if you can lower the barriers for adopting privacy when people are given the choice, they will choose privacy over non-private if the trade-off is low enough, right? If the barrier is low enough, and it's been so high for so long, like when I think about the evolution of privacy enhancing technology, we've gotten to a place where we have tools in the toolkit that are actually robust enough to where we can give them to developers and they can build applications where they're not worried about latency and computation speed and costs. We've lowered those barriers a lot. There wasn't an option before. So people could care about privacy, but I fundamentally believe that if we can first lower the barriers for developers so that they start building applications, because there are so many developers in the world who do care about privacy but just can't build with it because the costs are too high. And if we get them to start building with privacy as a fundamental part of their apps, then consumers, when presented with a choice of, well, do I go with the private ChatGPT or the OpenAI one where I know they're keeping all of my data and I know they'll give it to the government, if the trade-off between that choice is low enough, consumers will choose privacy. And so it's all about, for us in this space, about how do we lower those barriers to make that trade-off as little as possible so that people will choose privacy at the end of the day.
Yeah, I think that makes sense. I'm wondering, social media is probably especially a hard case because of the network effects, right? I think especially there, like the switching costs are probably tricky to adopt some sort of privacy preserving social media app instead of the one that everyone is using, right? But like you said, for example, if I use ChatGPT or a privacy preserving version, if the models are competitive, at the moment we're seeing that even open source is quite competitive and the models are getting smaller. So you get like the similar utility. If there's no huge network effect there, and if it's just, for example, from a developer standpoint, just switching out a few lines of code because it's an OpenAI compatible API, then maybe it's easy to do that move and then to gain privacy as well.
Yeah, and that is actually really what we are trying to showcase right now at Nillion. We actually launched about a month ago what we call NilGPT. You can go check it out, nilgpt.xyz, which is a open source model. We're running DeepSeek R1 and Llama, the 70 billion parameter model, inside of the blind computer right now, and utilizing our NilDB storage side, where we have secure storage and user permissions and user access to store information, all the chat history and everything, in a way where nobody has access to that data. But you as a user, when you go and you log in, you can go and call on that information, use it in NilGPT, which is privacy maintained and how it's doing inference. And then all of that is, say, disappearing, if you will, or turning into nothing at the end of the day. So you now have a place where you can do private inference and not worry about an open AI keeping all of the records and, turning them over to the government if they ask for them. And so we're trying to showcase the potential of what we can do with AI on the LLM side. But I think really when we get to we have an opportunity to step in front of the let's say wave of AI that is coming or has been coming, is going to continue, and really insert privacy at this point instead of trying to go back and say change how social media is done, because you're right, the network effects are too strong there. But right now we're talking about one-on-one interactions with consumers where we can go and offer that privacy preserving tech. We can give them new infrastructure to run it privately and really have an impact on the development pathway of AI and the infrastructure that it's used. So there is a real opportunity here with AI to be a part of the development of it in a way where privacy is now injected into its growth.
That's awesome. Yeah, we were talking about this off the air because we're doing similar stuff at Oda AI around the privacy inference. So I really like this. And we'll put the links in the show notes. So yeah, let's get into that a bit then. Like, what is it? What is Nillion?
Nillion, at the end of the day, you can think about it as, I always think about it as at least an upgrade to the infrastructure of the internet. When the internet was first developed, it was slow and it was unsecure. And what became the primary, say, problem to solve in privacy for the internet was really around the moving of data between different places, right? How we communicate from, say, the server to your computer. And that's where HTTPS came from. That's where TLS came from. We were trying to find solutions for in-transit data. How do we keep data secure while we move it around? Because that was the most vulnerable point. We've reached a place now where we start thinking about things like crypto, we start thinking about things like AI, we think about open networks, we think about, say, the centralization of like all of this intimate data about us, to where it can no longer be just about the movement of data and keeping data secure when it goes from one place to another. We have to start thinking on a different level of security and control for users, and that's what Nillion really provides in what we call the blind computer. The blind computer is kind of what it sounds like. You can think about it as a computer that just focuses on running computation, but the person that's using it is wearing a blindfold. And so while you're doing compute on data, which you're doing on your computer all the time, you're doing on servers all the time, you have to remove the security on the data in a normal computer in order to work with it. So when you log into your laptop, you're removing the encryption and you're doing the compute and then you're locking it back up again. With a blind computer, what we're focused on is maintaining security on data the entire way through. So the transfer of data is secure. When it gets to the device where the computation is being done, it's being done in a secure enclave, or it's being done with cryptography on top of it. So that data is never exposed to an outside party. So you don't have to trust somebody when you're utilizing data. And that's a really big evolution in how we think about how data is used, because we've always had data unsecured whenever we've been trying to run computation. But in this new world where, we are going to be integrating AI on such a deep level in our lives, and we're going to be working with all the sensitive information, and we want to get the utility of AI by giving it all this information about us, we now have to start thinking about security across the board, even when data is being computed on. And that's what the blind computer really focuses on. How do we move data? How do we store data? And how do we compute on data, not just in a decentralized way, but in a way where privacy is always on top of the data so that you're never leaking information to any third party?
This is interesting. So what are some of the methods you use for this? I already, had a look, and I saw, a fully homomorphic encryption apparently, but you also use trusted execution environments, which can be like an isolated, secure element on the chip where the operator cannot see what's computed on there, or a virtual machine where you cannot see what's computed in there. So that would create the blindfold in a way, right? I like that imagery.
Yeah, when we think about putting blindfolds on data, there are a lot of different technologies. You mentioned some: fully homomorphic encryption, garbled circuits, multi-party computation. When we started Nillion, we were really focused on multi-party computation as a big part of our core offering. We were building with that technology, and it remains a part of the blind computer. But we have since expanded the way that we think about it as we've evolved and as we've seen the growth of AI, and we've seen the places where we really think that the blind computer can drive adoption. Multi-party computation, or MPC, is really good at some things and not great at other things. So processing speed could be an issue. The number of nodes that you're working with, so the amount of decentralization you can have, has to be limited. So maybe you can only have 3 nodes. You can't have 50 nodes. But that's also true of other privacy-enhancing technologies. So FHE faces a problem around the amount of computation time it takes to work with data that has fully homomorphic encryption as the security. Then you have TEEs, where you have this trusted execution environment where you're putting data inside of a very secure box. But at the end of the day, it's sitting on a server, and some guy with a gun goes in there, they can get access to it. It's also possible for somebody to install software that is, say, spying on what's happening in there. And so we looked at all of these technologies and really have a vision for the blind computer of bringing those different types of tech together in a way to where we can utilize the strengths of each, but also not utilize a technology where the, say, downsides are not necessary for the security that you're looking for. So when I think about a TEE, for example, we do use TEEs in Nillion. We are running inference inside of TEEs right now. That's really the only privacy container where you could run a model with serious number of parameters and serious functionality is inside of a trusted execution environment right now. And so we're building with that, but still using MPC for different parts of how we're incorporating data into TEEs, how we're storing data, how we are, say, sharding data and sending it to different nodes for storage. And so we're really actually focused on bringing multiple types of privacy enhancing technology together in a way that allows for us to drive adoption of privacy, but also speak to all these use cases, because something like AI, right? Privacy within that is so important that having an environment that, say, maybe isn't as secure as what you could get with multi-party computation and having a bunch of different nodes, but is actually functional and it can actually drive adoption, that is our number one priority.
Mm. Do you also use zero knowledge proofs in some way?
We don't incorporate zero knowledge proofs right now, but
Yeah.
there are some elements on our roadmap where we're looking at that as a potential solution. So for zero knowledge proofs, usually you're doing some sort of proving to another party who has access to the information. When we're thinking about, say, just how much compute power can we have? How can we do, all different types of computation? And we're not really focused on, say, proving something to be true, but more just running compute in a secure way. Zero knowledge proofs haven't been as valuable in trying to build out that part of our tech stack, but there are places where we're looking at it as a solution to integrate as well.
Yeah. What are some use cases at the moment around using Nillion and these primitives that you see?
The really big one we're focused on right now is around AI and what we can be doing with private AI. There's a lot of, I talked about NilGPT and a private inference, chatbot, just like ChatGPT in a secure environment. One of my favorites that I actually use pretty regularly is an application called Louis AI that we built, which is a private version of Fireflies, so the note-taking app. So now you have an application that is, say, you're uploading recordings or inviting to a meeting where it is recording that meeting, doing inference on top of the transcript of that meeting, creating summaries, takeaways, you can ask it questions, all of that. But now you're not giving that entire meeting recording to some third party that is basically saying, trust me, bro, I'm not going to look at it. You own the data, but we can just use it however we want forever and not tell you. We have a version of that Fireflies where we're inside of the secure environment. And so we can be recording internal meetings and getting summaries from it. We don't have to worry about the things that we talk about on there because it's not going to end up in somebody else's hands.
Yeah. And so can you clarify a bit about this? Because it is not a public blockchain, but it is like a decentralized network, right? Can you just tell me more about that?
So there's really two elements to the decentralization in Nillion. We do have a blockchain that sits underneath the blind computer. That we mostly use that for coordination. We use that for moving tokens around. It's really about utility and coordination of the network and payments on the network. But it's not the priority for us. We're not looking at it as, say, we are trying to compete in the world of layer ones where we need to build our own ecosystem. We want people to use our smart contracts and bridge over to Nillion to use the network.
But is it like a layer one, or is it are you using some other chain that exists? Or
our blockchain is a layer one right now, but the goal of it is really about that coordination piece. And so the decentralization that is really the cool part is in the blind computer, which sits on top of that blockchain, which really just does the coordination. And the blind computer is decentralized by having various different nodes that are working either with the compute side of what we offer or on the storage side. And they're basically coordinating to be able to run compute on data in a secure environment, or we are taking data and we are sharding it across multiple different what we call NILDB or NIL database nodes, where we are storing it in a way where one, it's secure and it can't be reconstructed by any one of the nodes. So you're preventing a collusion or basically a centralized attack on one of the nodes. But also where we can apply what we call nukes, which is a permissioning layer for users where they control that data and are able to bring that data together into the compute side to be able to use that. So recalling, say, your past meetings and information from your past meetings into the browser so that you can use that and ask questions around it. All that information is stored in NILDB, but it's the permissioning architecture that allows that data to come back together and be used by a user.
All right, interesting. So you kind of use the chain for settlement and things like that, but the whole computational piece is happening with those other concepts on a decentralized network of those nodes. Okay. And what sort of where are you at in the roadmap? Like what have you launched? What's next?
So what's out there right now is what we call NILCC and NILDB is the fundamental elements that we have of the blind computer. You can think of NILDB as an encrypted database or basically encrypted memory for the blind computer. So this is where information that users are putting into the network, it's being stored there. This is where it's permissioned. This is where it's spread out among multiple nodes and can be recalled by users to be for computation or for reconstruction, so you get access to data. And then there's the NILCC side or the NIL confidential compute side, which is where we're running the actual computations that people want to do. So when you're interacting with, say, private inference, you're doing that inside of NILCC. When you're pulling in the past chat history from your use of NIL GPT, that's being recalled from NILDB into NILCC to be utilized. So we have this compute piece and we have the storage piece that are together. We're working on the attestation piece for the NILCC side, so that you have that verification that privacy was maintained during the compute. And then underneath that is basically the NIL chain, which is coordinating all of that activity between the nodes that are sitting on top of it.
And can anyone run those nodes? Like, for example, a TE and provide that compute?
So right now we're focused on, say, enterprise partners and our validators as running nodes on Nillion Network, but where we have a pathway to decentralization, where we're going to create different variations of nodes that will allow members of the community to start to contribute resources and run on the compute side and also on the storage side. And our goal is really to be in a place where you could be somebody coming in with H100s and running inference on part of the NILCC side and providing compute for inference, all the way through to an old laptop somebody has that they're storing data on from NILDB and are getting rewarded for contributing to the network.
Right. And the storage, can you tell me how the storage works? Is that also in the TE storing data, the NILDB, I guess?
No, so this is utilizing encryption on top of what is a MongoDB architecture. So for developers out there, we took a MongoDB architecture and have applied cryptography on top of it to not only shard data and move it between different nodes in NILDB, but also maintain that security while it's in storage. So it's really a way to think about it is you're basically applying cryptographic security on top of data and then breaking it apart and moving it across multiple different nodes. And when you want to bring that data together, you're using this permissioning architecture we have where a user can go and say, hey, bring these pieces back together because I want to use this data. And if they're running compute with it, they can bring that into the TE. So it's actually existing outside of the compute layer in a database that is essentially purpose-built just for the storage and reconstruction of data.
Okay, and data is safe in transit again and goes directly into the TE. So, and once it's in the TE, you also have the guarantees there around confidentiality again.
Yep. Or you could call it together and bring it outside of the TE. You want it reconstructed. If it's an image reconstructed in your web browser, you want to move it somewhere else. You want to give, say, one of our partners who are building on top of Nillion and building applications access to that information to use inside of their application that's on your phone. All of those are potentials.
What kind of data is that, for example? And does this create any form of latency that's like significant or?
We haven't experienced anything that's significant on latency with data, especially when it's being pulled together with our partners. But we're talking about data where, say, recently we had a competition around sleep. With Stadium Science, where we're basically having like a sleep competition where people are importing data from Apple Health into NilDB. Then that data is being brought together and computes being run on top of it to decide who's where in the leaderboard and things like that. So that data around that's coming from your Apple Health, you're not passing that over to Stadium Science and just giving them access to all of the health data that's on your phone. What you're doing is just passing information into a system where compute can be done to get to the result that they want, which is who's the winner. And so that data is never revealed to them. It's never revealed to us in Nillion. But you can also, order that information, run compute on it to figure out really cool insights.
I feel like FHE specifically feels a bit like voodoo magic to me because you run like computation on encrypted data.
Mm-hmm.
That seems kind of wild as well.
Yeah, FHE is definitely a really cool technology. The hurdle that they have been facing the most has been that it can be quite slow. Like the latency can be quite high, the compute time can be quite high, and so it's really hard to do, say, a large number of computations with data. But in certain areas, like it can be a really, like I said, all of them have certain strengths, and FHE really does have a security strength of, hey, we can keep this data in a centralized place. We're not adding, say, a bunch of additional data that we have to on top of it that really blows up the size of that data, and then we can run compute on it locally without actually revealing any of the data. So it's really cool tech, but the limitations are really around, what is the compute time? You see something similar in the secure compute with MPC as well, where you can do, decentralized multi-party computation where you have multiple nodes that are doing compute on parts of data. There you're, dealing with more size of data. So storing data can be an issue with MPC because you have to, say, add more data on top of the data, which grows the size of the data that every node has to have. But the ability to run compute in a decentralized way, really cool mechanism. You've got multiple parties who only have parts of data working on it and then bringing it together in the end.
Yeah, I think Zama works on the FHE bit, right? The project Zama.
Yeah, Tama's definitely been one of the big leaders in the FHE space and really been pushing the technology forward for sure.
Right. And you were saying, I don't know if you got to that, like what's next that is exciting for Nillion.
Well, I think that, when we look at what we're deploying with the blind computer, what we're doing in AI, and really, I think the architecture around building with AI on Nillion, that's going to be really the next major release that is coming up for us, which is going to be really, really cool. We've been developing what we call Nil AI, which is essentially a module that exists on top of the blind computer that is focused on the tooling and architecture for working with AI models. So you could utilize the models that we have running there, DeepSeek and Llama. You could create an environment to be able to run your own model, but then we're giving those tools to developers to where they can come in and build the next agent, or they can come in and build the next, private fireflies, or they can build the next, say, health data, inference system where they're pulling hundreds of people's data together and getting useful insights from it all in a privacy preserving way. And so those tools, I think, I'm really excited to put those in the hands of developers because they're the ones that are going to look at, say, what we did with NilGPT and what we've have in the tools of Nil AI and come up with the really cool use cases that are going to be the next driving force in things from agents all the way through to thinking about inference.
Cool. So does that come like with because you have your own programming language and SDK, does that have to do with that then, that you enable people? Yeah.
It's less about the programming language Nada, which is really focused on the MPC side, and really more about the tools of easily working with NilDB and working with NilCC and our trusted execution environments to build applications with it. So how can we reduce those barriers for developers to where they can use new technology like the blind computer and the pieces that make it up really easily? Because it could totally be a stumbling block where developers come in and it's like, okay, you've never worked with something like NilDB before because it hasn't existed until now. You haven't worked with something like that connected to a compute environment the way that the blind computer is. And so that can be a stumbling block for developers. We want to bring that down so that it's really easy for them to be deploying next generation applications.
That makes sense. So how do you see like the future going as we enter this sort of age of AI? I mean, we already entered it, but it's accelerating at such speed that you don't know what's next, right? Like literally from one day to the next. So what's your take on this? Are you like an AI doomer? Are you an optimist? Are you somewhere in the middle? Are you optimistic for the privacy piece and all of it? Yeah.
Yeah, I mean, I definitely say that like I'm an AI realist. So I'd say, I think that a lot of disruption, a lot of change is going to come from AI. But I also think that, when I look at what happened in the world of Web 2 and with social media, the tools that AI is going to offer us, we're going to be put in the exact same position around privacy again, which is, people making the trade of wanting utility more than they want privacy. And so really the best way to impact the development of AI is going to be around building infrastructure that supports privacy now. And for us, I'd say, it's less about trying to say, build an environment where we can run the next, 104 billion parameter model or the next ChatGPT 5 or 6. We're never going to keep up with that arms race that is happening right now. It's really about what comes after that, because what comes after that is going to be models that are much more focused on, say, specific use cases, specific outcomes, acting as specific types of agents. Those are going to be smaller. They're going to be, say, more more geared towards being really good at certain functions. You're not going to need everything that a like ChatGPT 6 will have inside of it. It doesn't make sense for something that's focused on like helping you, book holidays, right? And so those smaller models are the area where I think we can make the biggest difference, because that's really what's coming in the wave after this arms race that's happening. We're going to have a ton of these models that are going to be deeply integrated into our lives, that will need access to all this information, that will need permission to use your credit card, that will need to access your email, that will need all this information about you in order to provide the productivity enhancement that we're looking for. But we can build the technology and the infrastructure to support that now. So when developers are coming around and saying, okay, I want to build agents that are going to accomplish this thing, then they can do that inside of a private world, and privacy can be a part of the implementation of that tech. So, I'm not a super doomer on things at this point. I do think AI is going to fundamentally change things in the same way that, say, the Industrial Revolution did. Looking around now, we've got light bulbs and we've got phones, and everybody's shirt was made in a factory, and that's really cool. But when the Industrial Revolution was happening, it wasn't a super fun time to be alive. And I think we'll experience something similar in terms of disruption, but really the productivity enhancement, the impact that it's going to have, I think is going to be good for humanity overall.
Yeah. You guys also have some fun short videos on the website, which we can link in the show notes.
Yeah, the nil pill.
The nil pill, yeah. I like that. Yeah, I mean, thank you, Alex. That was really lovely, a topic that I like to talk about. So yeah, thank you for coming on the show.
Absolutely, I enjoyed it as well.